So we had a problem with the glass board when we originally recorded this.
Right, yeah. Blue marker and blue shirt is not visible.
Yeah.
So that's why we magically change clothes.
Right. So that so that's what we're doing. So we're gonna draw. I'm gonna draw the ship, a little triangle here, and Julie's gonna draw a triangle, and my ship is going to be firing its thrusters, and I gotta remember which way it's gonna go. So I'm gonna draw counterclockwise. So my ship is going to be firing thruster this way. So it's gonna be doing F thrust. Because the difference between the planetoids with torque and the old planetoids is now we have these thrusters on the front and the back, and so I can thrust this way, and I can also fire the thrusters this way. Up thrust. And you can do the opposite. And so the idea is that you know, we can get it rotating, or if it's already rotating, we might be able to slow down that rotation or speed it up.
And then they both need to be divided by 2 because you're doing half the thrust in each direction.
Yeah, so it's kind of like the rocket has an engine that can give a maximum of F thrust in whatever direction, and so we can do half that thrust in the front and half that thrust in the back. And then the length of the
ship is just this here.
Yeah, so that's going to be L ship. Right? Okay. So we got to think about how much torque this is, right? Because the torque is the force times the lever arm, and that's what we have to put in the program. So the net torque, and it's going to be slightly different in the two different cases because the thrust is in
different directions, right?
So the net torque is always the force times the lever arm. In particular, it's the perpendicular force. And, you know, and these forces are perpendicular to the axis of rotation, right?
So we're good there.
Here's the center, right? And so in this case, I've got, in the front, I've got F thrust divided by 2. I'm just going to call that FTH for short. F thrust divided by 2, and then what's the lever arm here?
So just L ship?
Well, L ship is the whole length of the ship. We're rotating around the center.
Oh, so half of L ship?
That's right. So
L ship
we
went right from there.
Divided by 2. And then I have to think about which direction the torque is. So it turns out that according to the right-hand rule, if the torque is this way, counterclockwise,
that way,
then the torque is positive. And so I'll put a positive there. For you,
going clockwise, so it's negative.
Negative. And so that's the torque from just the front thruster.
And we have to add the second torque.
The second torque, so did I say torque?
Torque?
I said torque. Torque, not twerk, torque. And so this, even though it's going this way, it's still going, for me, it's still going counterclockwise. So it's still a positive torque, right? So it's going to be plus, I'm going to put it below, actually, because I'm running out of space there, plus F thrust over 2, and the distance to the rotation is L ship divided by 2 here. Okay, get rid of this thing. Okay. And then for you,
so it's plus a negative F thrust divided by 2 times L ship divided by 2.
Right. Now, why is it still a negative for you?
Because it's still, the torque is still in the same direction, right?
Yeah, so it's still clockwise for you. It's clockwise whether it's this way for you
or whether it's that way. Yeah, it's just sort of different parts of the circle.
Right. Whereas for me, it's trying to get the thing, it's trying to get the ship to go counterclockwise. Right.
So then if we multiply that, right. So half times a half is a fourth.
Right. Yeah. So 2 times 2 is 4. 2 times 2 is 4, so a fourth plus a fourth is a half. And so at the end of the day, the net torque on here is F thrust times L ship, just divided by 2. Right? Okay? And then for you, it's the same thing.
But it's just negative because it's in the opposite direction.
So now all we got to do is put this into the code, in the part of the code where it, I think it's called torque thrusters. What is the variable?
Yeah.
So we just got to put that into there. Great, we did it. Let's do
Awesome.
it.
Let's go.